Hello, I'm Mr. McBrien. This is TEJ3M, Arduino 2 Programming Basics. Yesterday we had a look at our first Arduino Sketch and got to look at the Arduino in action for the first time. Today we're going to look at starting to build our own devices and make our own code. In order to do that, we have to work our way through some very basic ideas of Arduino programming, and that's what we're going to do today. We're going to differentiate between single and looped commands in our simple Arduino sketches. We're going to learn how to comment our code. We're going to learn how to interact with the Arduino through the computer connected to it. And we're going to learn how to accept inputs from the user. Finally, we're going to, instead of using an onboard LED in the Arduino, we're going to use the output pins that we configure and connect our own breadboard. So a busy day for today. Now, there are lots of commands in the Arduino that are done once and once only. We have to declare our variables, more on that later. We have to open communication between various devices. And we have to do lots of other things that might be just setting up our device for the first time. On the other hand, with any kind of automation, it's common to do things multiple times, to put in place loops. And some examples of this, well, the basic idea is keep doing this until you need to stop. More on that later. We already saw our blinking LED. We can also see loops where we want to monitor for a given input for something to happen. So the basic Arduino sketch, we want to first identify what we want to run once, identify what has to be done throughout the entire operation of the device. And the basic sketch, when you create a new one, supports this idea. So we have this setup section at the beginning where we can put in the commands that only have to be done once. And we have the loop section after that with things that just keep getting done over and over again until power is disconnected. So we have this idea of coding, which we haven't really unpacked yet at all. But it's important that we discuss one good practices concept before we go any further. And that is this idea of how you communicate with someone who reviews the code. Virtually every computer language has the idea of comments. So we can put inside our uncompiled code some comments to the person who reviews that code, whether it's your coworker, your manager, or just the you 3 weeks later who doesn't remember what you did. Comments, it's important to realize that they get ignored by the compiler. They don't change the way the program executes at all. All good programs are commented appropriately. It's a habit you need to get into. It's there so that other programmers can follow the purpose of the code, see why you did it at a later point in time. So in the Arduino code, any characters that come after those 2 forward slashes are actually comments. In our course, all evaluated code, all code that's submitted for evaluation must be appropriately commented. Those comments will include a header with the name of the programmer, the date, and the name of the program, and a brief description of what the program does. And each major subroutine should also be labeled with some words about their purpose and potentially some kinds of inputs and outputs that might be used with them. If you want to get the highest possible marks, you must do good commenting. This is the communication portion of this. And this is a common across all courses in programming. Now, the commenting tool is actually a powerful tool for debugging your sketches as well. So there'll come some times when you want to disable some portion of your code to essentially see how your sketch will work without that aspect of the code. You don't need to delete that code. You can simply highlight it, right click, and choose comment. This will comment out that code so that it isn't used in the compilation. When you're finished and you want to re-enable that code, you can simply highlight the comment and choose right click uncomment to put it back. And this is an extremely powerful tool for testing your implementations. An even more powerful tool is the computer screen for the computer that's attached to the Arduino. And you might ask yourself, why would you bother working with that screen? We're supposed to be making these portable, mini, compact devices. Why would we want to have that big, cumbersome screen there? Well, the answer is that a simple Arduino has very little capacity to communicate with a user without attaching additional hardware. In fact, all it really has is that onboard LED to communicate with the user. However, when you're writing your sketches, you're going to need to know what your Arduino is thinking, what it's doing. This is particularly important when you're developing code. So, while most Arduino applications involve it being detached from the computer, while you're coding it, you'll have it plugged in, and there is a special command that allows the Arduino to communicate back to the user using the monitor. So you can go ahead and review how to do that, but this is an absolutely critical skill for you to have. The ability to incorporate print commands so that the Arduino can tell you what it's doing at any given time. So here are some of the commands here. You need the serial begin in your setup. This is one of the commands that only happens once. And typically we'll just put in 9600 baud communication. That's sufficient for most purposes. After that, you can communicate to the screen through various commands. But you can also read values from the screen, so the user can type in values that you can then use in some logic as you're working. A typical application of this would be before you have the sensor that you need, you can have the user input a value that sensor would normally read. So if it's on back order from your supplier, you can still have the user type in the values that would be there. So I'd invite you to play around with those commands. They are absolutely critical to your success in developing Arduino applications. So mess around with them and see what you can do with it. But do not attempt to develop Arduino applications without understanding how to use the serial monitor. It is your #1 tool for debugging applications. I already alluded to accepting user input. The serial.read command is how you can do this. The system can check to see if the user has put anything in, and you can set up loops that wait for the user to put in values where appropriate. Later on, we'll use those same kinds of loops to watch for things like button pushes and other communications that don't involve keyboards and monitors. Okay, so your first activity then, I'd like you to experiment with the serial monitor output, change your blink sketch from yesterday, and add in a line to communicate to the monitor each time your LED lights up. Now, as soon as your sketch is running, you will need to go to the menu and enable the serial monitor from the IDE. but you should, each time that the LED lights up, you should see the word blink printed into the serial monitor. Okay, that's some debugging technology, that's some development technology, and it's incredibly important. Now let's talk about one of the core reasons we wanted the Arduino, the ability to accept and generate electrical signals. To do this, we have to use the input and output pins on the board. Now, there are two kinds of output pins, digital and analog, and we'll talk more about the analog ones later. For now, it's enough to say that the output of a digital on is 5 volts, off is 0 volts. We have to declare given pins if we want to use them. So those pins have to be set up initially. A variable needs to be assigned such that given pins will have their output generated once you're running. So don't forget to declare those pins you want to use, and you can see the code here. Now, you have your blink sketch that you just used with your serial monitor work. Review your code from there. Can you see where you declared the pins for that? It is critical to be able to declare the pins effectively, to know which pins you're outputting at what time. And this brings us to activity 2, connecting the breadboard. You can take your blink sketch one more time, and instead of outputting to the onboard LED, configure a breadboard with a 1000 ohm resistor and an LED. Connect your breadboard's ground to the Arduino ground. Connect your LED to pin 9. Remember, make sure it's a polarized component, so make sure that the positive end of the LED is connected to pin 9. And you can go ahead and blink pin 9 instead of, blink your breadboard's LED instead of the onboard LED. Now, this leads us to a key concept. Remember that you need to ground your breadboard and your Arduino. They need a shared ground. Many students will forget that ground and wonder why they're not getting any results. So you've got to remember this connection right here. The Arduino and the breadboard sharing the reference potential. In many cases, you won't bother sending 5 volts across to the breadboard from the Arduino, but you've got to have this ground. You have to have the reference potential. Okay, if everything's gone very smoothly, you'll have some extra time on your hands. What you should do now then is design your sketch to accept an input from the user. So instead of pushing information out to the serial monitor, accept it from the serial monitor. You'll need to look up the reference for this. And you can modify your LED pattern in response to the user's input. For example, faster or slower, this kind of thing. So, summing up then, the key things we need to take away from this discussion today: we need to be able to declare our pins to be able to use our output. We need a serial monitor, especially for troubleshooting our sketches. Always got to remember to share the reference potential between the Arduino and the breadboard. And remember, if we want great marks, we've got to comment our code. So for your homework then, go ahead and finish those serial monitor and breadboard activities. There are some references here for use in terms of pin mode and the serial monitor. Of course, you can just work online to find those things. A simple web search will find you great references for those as needed. I hope this helps. Thanks very much, and have a great night.